Lesson 68, Mutually Exclusive and Inclusive Events. Mutually exclusive events cannot occur at the same time. So the probability of mutually exclusive events can be found if A and B are mutually exclusive by adding the probability of A plus the probability of B. Those are two separate events happening. So for example, if I were flipping a coin and rolling a number cube, and I wanted to know the probability of flipping a head and rolling a 5. Well, the probability of flipping heads would be 1 out of 2, plus the probability of flipping or rolling a 5 would be 1 out of 6. So I'd have to change this to 3/6 to be able to add them, which would give me 4/6, which would tell me that my probability of that happening would be 2/3. What is the probability of rolling either a sum of 5 or a sum of 12 using two different number cubes? Okay, so we're talking about sums here, which means I have cube 1 and cube 2. So I need to know the sum. If I roll a 1 and a 1, I would get a 2. A 1 and a 2, I would get a 3 for my sum. So I can just fill those in. You should be doing this on your own paper also, so if you need to pause so that you have time to make up your table, please do so, because you will be expected to have this in your notes. Alright, and what I want to know is the probability of rolling a sum of 5 or a sum of 12. So the probability of a 5 or a 12 can be found by finding the probability of getting a 5, a sum of 5, plus the probability of getting a 12. Well, the probability of getting a sum of 5, I have 1, 2, 3, 4 5s out of 36 possibilities, which I can find by taking 6 times 6. Whoops, didn't mean to make that line there. So I just said that that was 4 out of 36, plus the probability of getting a sum of 12. I only have one sum of 12, and I would have to roll a 6 and a 6 to get that. So it's going to be 1 out of 36. I add those together. 5/36 is my probability of getting a sum of 5 or a sum of 12. Inclusive events can occur at the same time. So the probability of inclusive events, if A and B are inclusive, then to find the probability, we take the probability of A plus the probability of B minus the probability of both. And I'll show you what I mean by that. You need to make sure you have that in your notes. So we're doing the same thing here. What is the probability of rolling at least one even number or a sum of 10? Sum of 10. Using two number cubes. So I'm going to have to fill in my table again. I have okay. So I want to know the probability of rolling at least one even number or a sum of 10. So probability of an even or sum of 10. So that's going to be found by finding the probability of rolling at least one even number plus the probability of rolling a sum of 10 minus the probability of rolling an even number. I shouldn't have put the P in parentheses there. Probability of rolling an even number and a 10. Okay? So, the probability of rolling at least one even number, I'm going to change the color of my pen here so I can mark on this. Okay? Even numbers, on the first number cube, if I roll a 2, all of those are if I roll a 2. The next even number on my number cube is 4. All of those are if I roll a 4. Next one is 6. Okay, that's just my first cube. So out of my first cube, I have 6, 12, 18 possible. Then I have to do the second cube also. So I could roll a 2, a 4, or a 6. So I had that 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 out of 36. And notice I didn't count these where they met twice because it just said at least one. I don't need to count it twice because that would be double dipping. Okay. Then it wants to know the probability of getting a 10, a sum of 10. I'm going to change my color again. So 10s fall here, here, and here. So the probability of getting a 10 would be 3 out of 36 minus the probability of getting an even and a 10. Well, that's going to be where there's blue and green. Not blue. How about red and green? So I'm going to change my color to blue to locate those. Well, this one has green and red, so that one would count. This one just has green. This one has green and red. So that probability would be 2 out of 36. So 27 plus 3 gives me 30, minus 2 gives me 28 out of 36 as my probability, but I need to reduce that, of course. So whenever I reduce it, I'm going to reduce by 4. So 4 on top and bottom. 28 divided by 4 is 7. 36 divided by 4 is 9. This is my probability. A town contains 5,890 people planning to vote for candidate A. 6,910 people to vote for candidate B. And 10,050 people planning to vote for candidate C. In a random gathering of 200 people, how many would you expect to be voting for candidates A or B? Okay, so we're just saying a random gathering of 200 people. So what I need to do is I need to find what the probability is of each candidate. So the probability of them voting for candidate A is going to be that 5,890 out of the total. So I have to find out the total number of people in the town. So I'm going to take 5,890 plus 6,910 plus 10,050, and that gets me 22,850 people. So I'm going to put that on my denominator here, 22,850. And if I divide that, I get, let me see if I have a nicer fraction. Nope. Okay. So I'm going to estimate that to be 0.258. Okay. The probability of candidate B will be that 6,910 out of 22,850. So if I divide those, 6,910 divided by 22,850, and I'm going to estimate that one to be 0.302. And for candidate C, I would say that we have that 10,050 out of 22,850, and I'm going to divide, and I'm going to estimate that one to 0.44. Okay, and then all I have to do is multiply. So I'm going to multiply this by 200, multiply this by 200, and all it's asking me is how many I would expect to be voting for candidates A or B. Okay, they can't vote for both, so I'm just going to have to add these two things together. So if I take 0.258 times 200, it gives me 51.6. 0.302 times 200, that gives me 60.4. So I'm going to round those because I can't have a 6/10 of a person or 4/10 of a person. So I'm going to say this one's about 52 people and this one is about 60 people. So the probability of them voting for candidate A or B, I would find by adding those two, which is going to give me 112 people. Hayley has a bag of marbles. 13 have yellow in them, 16 have green in them, 23 have red in them, 8 have blue in them, and 6 are multicolored. The multicolored marbles have red and blue. If Hayley randomly selects a marble, what is the probability that the marble will be red or blue? So, the probability of getting a marble that has red in it, okay, out of all the marbles, let's see. She has 13 that have yellow, 16 have green, 23 have red, 8 have blue, and 6 are multicolored, which are red and blue. Okay? So, I want to know the probability of her getting a red or a blue. Well, this is going to be the mutually inclusive because I can get the same thing I can get it at the same time because of this red and blue multicolored. Okay? So what I'm going to do is I'm going to find the probability of getting a marble with red. Okay? So I'm going to finish out my equation. Probability of getting a red plus the probability of getting a blue minus the probability of getting a red and blue. Okay? Alright. So, the probability of getting a red is going to be the red marbles, which is 23, plus those multicolored marbles because they have red in them. So that's 6. So that's going to give me 29 out of, I have to find the total in the bag. So I'm going to have to add all those up. So I have 13 plus 16, oops, I'm hitting the wrong button. 13 plus 16 plus 23 plus 8 plus 6 gives me 66 marbles in the bag. Plus the probability of getting blue, I have 8 blue marbles and those 6 multicolored, so that gives me 14 out of 66, minus red and blue, which is just that 6 out of 66. So then all I have to do is the math. So I have 29 plus 14 gives me 43 out of 66, minus 6 over 66. Whenever I subtract these, I'm going to get 37 out of 66. And that is my final answer. That is all I have for you. I hope that you have a good night.